Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, in this video we are going to study about the characteristics of transducers. There are three characteristics of transducers: input characteristics, transfer characteristics and output characteristics. So we are going to study about these three characteristics of transducers in this video. So let us start with our topic. Whenever we are choosing a transducer for a particular application or for a particular type of measurement, we have to consider the characteristics of transducer while choosing a transducer for that application. So we can say that these characteristics are very important in the choice or in the selection of transducers for a particular application. If we see the characteristics of transducer, there are three types of characteristics of transducers: input characteristics, transfer characteristics and output characteristics. These characteristics of transducers, they are influenced by various factors. Like in input characteristics, the input factors are going to influence these characteristics. Transfer characteristics means both input and output are involved in that, and output characteristics means output factors are involved in that. If we see the factors which influence these characteristics, so input characteristics, it is influenced by two factors: type of input and operating range. And second factor is loading effects. So these are the two factors which influence the input characteristics, or we can say that the input characteristics depends upon these two factors. If we talk about transfer characteristics, it depends upon three factors: transfer function, error and response of transducer to environmental influences. If we talk about output characteristics, it also depends upon three factors: type of output, output impedance, and useful range. Okay, so there are three types of characteristics of transducer: input, transfer and output, and all these three characteristics depends upon different factors. Let us study these characteristics in detail one by one. First we will start with the input characteristics. First factor, as I have said, which influence the input characteristic is the type of input and operating range. So first factor, that is type of input. It is the first and the foremost consideration whenever we are choosing the transducer for a particular application or for a particular measurement, because the transducer, it measures a physical quantity and convert that physical quantity into an electrical quantity. Okay, non-electrical quantity is converted into an electrical quantity. Now there are various types of parameters that can be measured by the transducer, by a single transducer, and also it is possible that one physical quantity, it can be measured by several types of transducers. So according to our application, it becomes a choice that which transducer we have to use for that particular type of measurement. Like if we want to measure the displacement, or if we want to measure the resistance, pressure, temperature, so depending upon the type of measurement, we are going to use the transducer for that particular application. So first consideration is the type of input, what type of input we want to measure from that transducer. Second is the operating range. Now operating range, that is the useful range in which the transducer is working. So this range is going to have an upper limit and a lower limit, and the transducer, it has to perform very accurately, or it has to give its 100% performance in this operating range. Okay, so both these type of input and operating range, they are going to decide the input characteristics of the transducer. So whenever we are using the transducer, whenever we are selecting a transducer for an application, first and foremost consideration is the type of input which the transducer is going to measure, and second is the useful range of the input quantity over which the transducer has to work. So how this useful range is being decided? Now this range is going to have an upper limit and a lower limit. So upper limit is decided So this is how the upper limit and the lower limit of the operating range of the transducer is decided. Upper limit is decided by the capabilities of the transducer, that in what range it can work, or what conditions it can withstand. So according to that, upper limit is decided and lower limit is determined by the transducer error, or by the unavoidable noise originating in the transducer. And it is expected that the transducer, it is going to maintain a good resolution in its complete or throughout its operating range. Okay, so that in that operating range, the transducer, it can give its 100% performance, 100% efficiency should be given by the transducer. So that was the first factor on which the input characteristics depend, that is type of input and the operating range. Second is the loading effects. If we talk about loading effects, ideally a transducer, it should have no loading effect on the subsequent stages in the measurement system, because in a measurement system not only a transducer is there but also several other components are present. So it is expected that the transducer, it should not load the other stages after the transducer. So to have no loading effects, the output impedance of the transducer should be very high. Okay, then only the loading effects will be neglected. Now what this loading effect causes in the transducer, if loading effects are present, then force and energy will be extracted from the input quantity. The input quantity which the transducer is measuring, that will be reduced. Okay, so in the output of the transducer, we will not get the accurate or the correct values of the measurement. So loading effects have to be reduced in the transducers. So ideally a transducer, it should have no loading effects on the input quantity being measured. Now when we express the loading effects, the magnitude of the loading effect is expressed in terms of the force or the energy or the power extracted from the input quantity. So if some energy or force or power is being extracted from input quantity, its magnitude will be reduced, and at the output of the transducer we will not get the correct results. So that is the cause of the loading effect or the effect of the loading effects. Okay, so it some measures have to be taken or some steps have to be taken so that the loading effect should be minimized in the transducers. So the magnitude of loading effect is expressed in terms of the force, power or energy extracted from the quantity under measurement for the working of the transducer. And the transducer which we are selecting for that particular application, it is expected that ideally the transducer, it should not extract any force, power or energy from the quantity under measurement so that it can be accurately measured by the transducer. So we can say that in a transducer, ideally the transducer should have no loading effects on the input quantity which is under measurement. So the input characteristics of the transducer, it depends upon these two factors. First was the type of input and the operating range, and second was the loading effect. Okay. Now comes the transfer characteristics of the transducer. So as we studied earlier, that transfer characteristic, it depends upon three factors. First is the transfer function, then error, and third is the response of the transducer to the environmental influences. So first we will start with the transfer function. If we talk about the transfer function, then it is the relationship between the output and the input. And if we talk about the transfer function of a transducer, then also it is the relationship between the output and the input quantity which the transducer is measuring. So if we define transfer function of a transducer, so transfer function is the relationship between input and the output quantity. If we write its formula, then transfer function is Q naught equals to a function of Qi, where Q naught is the output of the transducer and Qi is the input of the transducer. So you can say that this transfer function, it is defining the relationship between the output and the input quantity. Okay. Now if we define another term which is called the sensitivity of a transducer, then sensitivity is defined as the differential coefficient. So its formula will be S equal to d Q naught upon d Qi. So Q naught is the output, Qi is the input. When we are taking their differential coefficient, then it is called the sensitivity of the transducer. Another term is called the scale factor. Scale factor is the inverse of sensitivity. So it will be 1 by S, that is inverse of sensitivity. So dQi upon dQ naught. So these terms, that is transfer function and sensitivity and scale factor, they decide the transfer characteristics of the transducer. And when we are selecting the transducer, we have to keep in mind that what is the relationship between the output and the input quantity, or we can say that we should know the transfer function of the transducer. Second factor which affects the transfer characteristics is the error. Now, why these errors occur in transducer? We have said in the transfer function that the output and the input quantity, there is a relationship between them, okay, which is given by the equation Q naught equals to F of Qi. That means output is a function of the input quantity. Now, when the transducer does not follow this relationship and it gives us a different output, then in that cases error occurs. Okay, so the reason behind the occurrence of error in transducer is that they are not following the relationship Q naught equals to F of Qi. So due to that, a different output is being obtained. So if any departure or any deviation is seen from this relationship, that will result in an error. Suppose that on account of, suppose that we are giving an input Qi to the transducer and we are supposed to get the output Q naught, but due to the errors, the Q naught output is not obtained and a different output Q naught dash is obtained. So in that case, error will occur in the transducer, and that error in the transducer is given by E equals to the output which we are getting from the transducer minus the actual output which we want to get, that is Q naught. So E is the error. Okay, means the measured value of the output minus the actual value of the output. Okay, so this is called the error. Now this error, it can be split into three components. Okay, means there are three types of errors that can occur in the transducers. First is the scale error. Second is dynamic error. And third is error due to the noise and drift. Now the first type of error, that is the scale error. Scale error means scale is the part which is giving us the relationship between the input and output, that how the output is changing with the time, that is shown on the scale of the transducer. So if any changes are taking place in the relationship between input and output, that comes under the scale error. Now scale error is also divided into different parts. First is the zero error. There are different types of scale error. Second is the sensitivity error. Third is the nonconformity. And fourth is hysteresis. So all these four types of errors, they are going to affect the scale, that is the relationship between the input and the output. Let us first study the zero error. In this type of error, which is called the zero error, the output is going to deviate from the input by a constant factor. Okay, means over the complete operating range or over the complete scale of measurement, the output is deviating from the input by a constant factor. Okay, so that is called the zero error, and that is over the entire range of the instrument or the transducer. Okay, so output is going to deviate from the input, or we can say that it is going to deviate from the correct value by a constant factor. Over the entire range of the transducer. Now if we draw the graph for the zero error, which is showing the relationship between the input and output. Suppose this is when we are changing the input, this is the actual output which we should get. Okay, but due to the zero error, we are getting a different output, and this output is deviating from this actual value by a constant factor, which is called the error. So this dashed line is the theoretical curve, or we can say that the ideal curve which we should get, but practically we are getting this curve. So you can see that over the entire range of the transducer or over the entire range of measurement, a constant error is occurring in the instrument. Like if we take an example that when we are starting the measurement, the scale, the indicating scale of the instrument, it is not at the pointer 0. Okay, ideally it should point towards 0 because we are not doing any type of measurement, but it is not pointing at 0, it is at somewhat 0.1 or 0.01 value. Okay, so this constant error is going to present in all the measurements. Okay, whenever we are doing any measurement, this 0.01 or 0.01 this value will be added in the actual output. Okay, so that is called the zero error. Next type of error is the sensitivity error. Now we are talking about, first we talk about the zero error. So zero error was the constant factor that a constant factor, by a constant factor the output is deviating from the input. But now in the sensitivity error, the output is deviating from the actual value, that is the correct value, but there is not a constant value. There can be any ratio in that, or any proportional constant will be there. Okay, it is not necessary that always means as the range is increasing or as the input is increasing, the error is also increasing in the output. Okay, but in the zero error there was a constant error over the entire range. Okay, so that is the difference between zero and the sensitivity error. Okay, so the observed output, it deviates from the correct value by a constant value. Okay, here you can see that we have not written that it is over the entire range. It may be possible that on the lower limits of measurement the error will be small, at higher limit, upper limits it will be more. Okay, so suppose that observed output is Q naught. Okay, and the output which we are getting, or the practical output which we are getting, is K Q naught. Okay, so this output is deviating from the actual output by a constant factor which is the K. Now if we draw the relationship here, it will be the input, output. Now theoretically we should get a curve like this. So theoretically we should get the curve like this, but actually practically we are getting a curve like this. Okay, so this is the theoretical curve and this is the practical curve. So theoretically the output is Q naught, but practically we are getting K Q naught, and this, the difference between the theoretical and practical value, is the error. Okay, so that is the sensitivity error. Now comes non-conformity, that is third type of error. So this non-conformity error, it occurs whenever the experimentally obtained transfer function is it is deviating from the theoretical transfer function for almost every input. Okay, means when we are doing experiments on the transducer, the experimental transfer function, it is different from the theoretical transfer function of the transducer, and for every value of the input we are getting this deviation. So that type of error is called the non-conformity. If we draw the relationship between input and output, so you can see that for every input we are getting the deviations. Okay, for every input the theoretical and the practical value of the transfer function. Transfer function is what? The ratio of the output and the input. Okay, so every point you can see that the practical curve, it is deviating from the theoretical curve. Okay, so that type of error is called the non-conformity. In special cases, this non-conformity error is called the non-linearity or the non-linear distortion. Whenever the theoretical relationship between input and output is a linear relationship and the practical curve is deviating from that, then in those cases we call the error as the non-linearity or the non-linear distortion. Okay, next type of error is the hysteresis. Now all type of transducers, they are affected by the hysteresis. There are cases, the hysteresis, it occurs in those cases when the output of the transducer, it is not affected by the current input but also the past values of the input also. Okay, so when we are increasing the input we are getting a particular output, but for the same values if we are decreasing the input in the same range, we are not getting the actual output which we were getting earlier. Okay, a different output is obtained. Suppose like we are having the operating range of the transducer from 0 to 50. Okay, now we are increasing the input of the transducer, so we are getting an output value. Okay, like in the range 0 to 50, when we are increasing the input we are getting a curve for the output. But now when we are decreasing the values from 50 to 0, that is from full scale range to the lower limit, that is 0 value, we are not getting the same curve for the output. That is called the hysteresis. Okay, so for the increasing values we are getting a different output, and for the decreasing values of the input we are getting a different output. Okay, so here we can say that it occurs when the output of the transducer, it not only depends upon the current input but also on the previously applied values of the input. So hysteresis occurs in those cases when the output of the transducer, it not only depends upon the input quantity but also upon the input quantities previously applied to the transducer. Now in those cases of hysteresis, a different output is obtained when the same value of input quantity is applied depending upon whether the input quantity is decreasing or increasing. If we draw the graph for the hysteresis, now when we are increasing the input values, we are getting the graph like this. Okay, now when we are decreasing the input, we are following the same values, okay, but we are getting a different output. So this is for the increasing input and this is for the decreasing input. So that's just the graph for the hysteresis. You can see that for the decreasing values, a greater output is obtained in comparison to the value of the output which is obtained when the input values are increasing. Okay, so when the input is increasing, we are getting an output, and when we are decreasing the input, we are getting a different output. So that is called the hysteresis. So the first part which was affecting the error, which comes under the error, was the scale error, and under that scale error we studied these four types: zero error, sensitivity error, non-conformity, and the hysteresis. Now the second component of error is the dynamic error. So the next type of error which is affecting the transfer characteristic is the dynamic error. Now dynamic error, it occurs on those cases when the input of the transducer is changing with the time. Okay, we are having two words, static and dynamic. Static means the value which is not changing with time, and dynamic means the value which is changing continuously with time. So here dynamic error, it occurs in those cases when the input quantity which we want to measure by the transducer, that input quantity is continuously changing with the time. Now this dynamic error, it is on account of the storage elements present in the transducer. Storage elements, like if a capacitor and inductor is present in the transducer, then these elements have the property to store energy in them. So these capacitor and inductor, they are known as the energy storing elements. So if the instrument, or if the transducer is having the energy storage elements, so due to that the dynamic error occurs. Okay, now for that, let's see an example that how this dynamic error affects the output. Let's consider the case of an RC series circuit. Now in this RC series circuit, we are having a resistance and a capacitor. So capacitor is an energy storage element. Now when a step input which is having magnitude E is applied to this RC series circuit, we will get an output. Also some voltage will be stored in the capacitor, because this capacitor will be charged to some voltage. So the voltage across this capacitor after the application of this step input, or we can say that after a time t, if we see the voltage across this capacitor EC, it will be capital E, that is the step input, its magnitude 1 minus exponential of minus of t by tau. Okay, where this tau, it is the time constant. Which is given by R C. So you can see that when we are applying the step input E, we have to get the actual output also as E, but due to the presence of this energy storing element, some amount of voltage will be stored in this capacitor, and that voltage is given by this. So if we calculate the error, which is called the dynamic or the measurement error, given by EMT, the difference between the output, which is E, and this EC, okay? So E minus this E 1 minus exponential of minus T by tau. So we are getting EMT as exponential minus T by tau. Now through this equation, you can see that this dynamic error, it is a function of time, because so we can say that as the time is increasing, the dynamic error is also increasing, and you can see that dynamic error is also a function of the time constant. So if we are having a small value of time constant, we can reduce this measurement error or the dynamic error also. Okay, so this dynamic error, it is on account of the storage elements present in the circuit or in the transducer, due to which the output cannot follow the input exactly, but there is a time lag or a time delay between the output and the input, and that is called the dynamic or the measurement error. Okay. Now next type of error which can affect the transfer characteristics of transducer is the error due to the noise and the drift. Now what is noise and what is the drift? Noise means it is a signal which is of random amplitude and random frequency. And drift is a slow change with time. So both these noise and drift, they are the unwanted signals in the output. Okay. Now when these signals, they originate from the transducer, they vary with time, means as the time it changes, the noise and drift signals, they also changes, and these signals are superimposed on the output signal. So we can say that the output signal from the transducer, it is contaminated by the noise and the drift signals. So errors can occur due to the noise and the drift, and the magnitude of this noise and drift, it is generally dependent upon the independent of the input quantity, and it generally depends upon the output quantity. It is going to affect the output of the transducer. So steps should be taken so as to reduce the effect of the noise and the drift, so that errors can be minimized. Next type of error is due to the change in frequency. Now when we are using a linear transducer, and to this linear transducer, if we are applying a sine wave, okay, so this linear transducer is going to produce an output which is also a sine wave, and which is the exact replica of this input signal. Now as the frequency of this sine wave is increased, so this linear transducer, it also has to rapidly respond or quickly respond towards the changes in the frequency, and according to that it has to produce the output. Now as soon as as we are increasing the frequency of the sine wave, there comes a particular frequency beyond which, if we are making any changes, the output of the transducer, it is not going to respond as quickly as the frequency is changing. So the output of the amplitude, it is going to fall, it is going to decrease, and also the phase difference between the output and the input, it is also going to increase, because in that case, because we are increasing the frequency to such an extent that the output is not following the input. Okay, and this roll off or this fall in the output amplitude is called the frequency response of the transducer. So this fall in the fall in the amplitude of the output, or the roll off of the amplitude of output with an increase in the input frequency, is the frequency response of the transducer. If we draw the graph for the frequency response, you can see that here we are describing the gain. Gain is what? The ratio of the output and the input. So the gain of the transducer, it is expressed in decibels, that is dB, and here we are having the frequency in kilohertz. So you can see that when the frequency is increased, so after a particular value, the output of the, or the gain of the transducer, it starts decreasing. Okay, so this is going to affect the characteristics of the transducer, or it is going to affect the selection of the transducer for a particular application. So we can say that not only the error which is occurring due to the change in the frequency, but also the high cutoff frequencies and the gain, or we can say the frequency response of the transducer, also causes errors in the transducers. Okay, so errors due to this change in frequency, it also has to be minimized. So now we have studied about the scale error, and we studied about the dynamic error. The third factor which is coming under, or the third component of the error, is the response of the transducers to the environmental influences. So this is also a factor which is going to affect the transfer characteristics of the transducers. We studied here that the transfer characteristics, they are affected by the transfer function and the errors in the transducers. But this transfer function and error, they will be minimized only when the transducer is working under the constant environmental conditions. If the environmental conditions are not constant, then they are also going to affect the performance of the transducers. Okay, so whenever we are selecting the transducer for a particular application, not only the transfer function and error, but also the environmental conditions has to be taken care for at the time of selection. Now, what are these environmental conditions which can affect the transducer? Here we are having the stray electromagnetic and electrical fields. So there are various factors which come under the environmental conditions, like if there is any stray electromagnetic and electrostatic field present around the transducer, if mechanical shocks and vibrations are present, if there is any changes in the temperature, pressure, humidity, if there are changes in the supply voltage, and also if there are improper mechanical mountings. So all these factors, they can affect the performance of the transducers. So for the transducer which we are selecting for a particular application, it should be guarded against, or it should be protected against these environmental influences, or we can say these interfering and the modifying inputs. Okay. So under this transfer characteristics, we studied the three factors which influence these characteristics. First was the transfer function, second is the error, and third is the response of transducer to environmental influences. Now next characteristics are the output characteristics of the transducers. Now the output characteristics of the transducer, they also depend upon three factors. First is the type of electrical output. Second is the output impedance, and third is the useful range. First we will study type of electrical output. Just like the input characteristics, they are depending upon the type of input which the transducer is measuring. Output characteristics depends upon the type of electrical output which we are getting from the transducer. Now the output of the transducer, it can be a voltage, it can be a current, it can be an impedance, or it can be a function of any quantity. Okay, function of the voltage, current, and the impedances. So the output quantity, it should be acceptable by the other stages of the instrumentation system, because as I have said that in a measurement or in an instrumentation system, we are not only having transducer, but there are also other components present in that. Now these components, they should be compatible with the output of the transducer. The output, the electrical output which the transducer is producing, that should be acceptable by the other stages of the measurement system, so that they can work over it. Okay, so here the type of under this type of electrical output heading, we can say that output from the transducer So the output of transducer, it can be voltage, current, impedance, or a time function of these amplitudes. Now these quantities, they may not be acceptable to the latter stages of the instrumentation system. So these quantities, they have to be changed. Either their magnitude has to be changed, or they have to be manipulated, or they have to be changed into some other form, so that they become compatible to the other stages of the instrumentation system. So this type of electrical output, it affects the output characteristics of the transducer, that what type of output the transducer is generating or producing. Next factor is the output impedance. The output impedance of the transducer, it is denoted by Z naught, and this output impedance, it has the main consideration or main importance when we are considering the loading effects. Under the heading loading effects, we also studied that the output impedance of the transducer, it should be very high, it should be infinite, so that it cannot load the other stages of the instrumentation system. Okay, so to reduce the loading effect, output impedance should be infinite. So we can say that output impedance, it determines the extent to which the subsequent stages of the instrumentation system, they are loaded. Okay, so ideally the value of this output impedance, it should be 0. So ideally the value of the output impedance should be 0, but there are practically some value of output impedance is always present, so some loading effect is always there in the instrumentation stages. Okay, now because this output impedance, it is affecting, it is the loading effect. So in the loading effect, we studied that it is expressed in terms of the magnitude of the power, force and energy extracted from the input quantity. So when we are expressing the output impedance, it determines the quantity of power, force extracted from the input quantity. Okay, now now, if we are talking about this loading effect, we said here that the output impedance should be 0, or we can say that ideally a device should have high input impedance and low output impedance. Now, if we compare the input and the output impedances of a transducer, if the output impedance is low compared to the forward impedance or the input impedance of the system, then the transducer, it will act as a constant voltage source. And if the reverse of this is there, that if the output impedance is high compared to the forward impedance, the transducer will have the characteristics of a constant current source. Okay, so you can see here that how the output impedance, it is affecting the characteristic of the transducer, that whether it will act as a constant current source or a constant voltage source. So here, if vice versa is there, then it will act as a constant current source. So this output impedance, it play a very important role when we are considering the loading effects in the transducers. Next is the useful range. In the input characteristics also, we studied about the operating range of the transducer, that the operating range of the transducer, it is decided, the upper limit and the lower limit, they are decided by, upper limit is decided by the capabilities of the transducer and lower limit is decided by the noise factor or the unavoidable noise which is present in the transducer. Okay, so here also the output range So the output range of the transducer, it is also limited at one end by the noise which can contaminate the input signal, and the upper limit, it is set by the maximum useful input level or maximum useful input value or input range of the quantity. Now if we want to increase the output range of the transducer, sometimes amplifier is added with the transducer so that its output operating range can be increased. But this amplifier, it can also introduce the noise and errors in the system. So the effect of adding an amplifier, it will be nullified, it will have no effect, and the range cannot be increased by the use of the amplifier. Okay. So here we studied about the three types of characteristics of the transducer: input characteristics, transfer characteristics, and the output characteristics. Also under these characteristics, we studied the factors which can influence these characteristics. Okay, so I hope that this topic, characteristics of transducer, it is now clear to you. Thank you.